Overtone music. This lecture describes how individual harmonic overtones can be employed in electroacoustic music as elements of a composition rather than as components of the spectra of individual tones. Of course, since overtones will produce a fundamental whenever there are enough of them, the subject becomes a matter of hearing both the overtones and the fundamentals in music. Spectra. As I have stated in my other lectures on this topic, most sounds that we hear in music are not the single tones that we hear as the pitches, but consist of many different tones that merge into a single entity. Those different tones constitute the spectrum of the sound, something that is usually perceived as the tone quality or timbre. We can't really speak of structuring them in instrumental or vocal music. Electroacoustic music is the first music that allows such a possibility. In musical notation, the notes that are indicated in the score denote pitches. Timbre or overtone structure is indicated by the instruments that play these pitches. The most important component of the sound that enables a listener to identify the instrument is the overtone structure of the sound, although many other factors are also important. Musical harmony books usually illustrate the overtone series in a chart like Figure 1, which shows the closest pitches to the first 16 partials of C2. To be sure, these overtones are not exactly the same as their tempered pitches. In order to clarify the extent to which they are out of tune, I need to explain the octave point pitch class system, or 8VE points PC, method of notating pitches, which is used in C sound and other synthesis programs. The pitch of middle C is near the frequency of 2 to the 8th power, or 256, and the frequencies of the tempered scale can be generated by raising 2 to the power of the octave plus n twelfths, where n is the semitone above C that you want. The result is then multiplied by 1.0219749, bringing A above middle C to 440 Hz, which is the international standard. Some European countries use a slightly higher frequency like 444 Hz. In octave point pitch class, the pitch of middle C is 8.00, and each successive semitone is raised by 0.01. A440 would thus be 8.09. C above middle C would be 9.00, and the value of 8.12 would also work. The lowest note on the piano would be 4.09, and the highest note 12.00. Fractions of semitones are possible, such that 8.005 would denote a quarter tone between C and C sharp. The main difference between octave point pitch class and the usual notation is that the octaves are numbered 4 higher. But this has the advantage that it provides a notation for subsonic and supersonic frequencies. This notation also works for intervals, where 1.00 would represent an octave and 2.07 would mean 2 octaves in the fifth. In considering the pitches of overtones above a fundamental, Figure 2 shows in octave point pitch class notation the interval above the fundamental in equal temperament for the first 32 harmonic partials, spanning 5 octaves above the fundamental. As the chart shows, the perfect fifths, 3, 6, 12, 24, major seconds, 9th, 18th partial, and minor third, 19th partial, are 2%, 4%, and 2% apart from the equal tempered pitches. The major thirds, 5th, 10th, 20th, are 14% flat. Minor sevenths, 7th, 14th, 31% flat. Major 7th, 15th partial, 12% flat. Minor 6th, 27th partial, 6% sharp. These are also within 1/10 of a semitone of their tempered counterparts. The one that is most out of tune is the tritone, 6 semitones above the note, the 11th partial being about halfway above the perfect fourth, 49% flat. This is one of the reasons why this note was so out of tune with medieval instruments, which were tuned by ratios, and the interval was referred to as the devil in music. The chart shows harmonic partials up to the 32nd, 5 octaves above the fundamental. Partials above this certainly exist, but they are very close together, and their pitches cannot be perceived independently unless isolated from their immediate neighbors or amplified. Spectral merging. It is a fact of our perception of sounds that the harmonic partials of a tone fuse into a single pitch and are perceived as the tone color of the sound. I have used the term spectral merging to describe this process. Spectral merging is likely to be a factor only when individual overtones are being employed. Two questions need to be explored are: 1. How many overtones are necessary to make the fundamental be perceived? And 2. What relationship between them is required? Milton Babbitt, who had experience with this issue when working with the RCA synthesizer, told me that you needed at least 3 consecutive partials to obtain the fundamental. I have found that the picture is much more complicated. For lower numbered harmonics, it may be easier to discern the fundamental in this situation, although that is not always the case. It certainly doesn't work when you have high ones, such as 17, 18, and 19. When a nondescript collection of harmonics includes the fundamental, that most often will take over as the pitch. All these ideas can be tested and will become clear in the examples that follow. While the overtones of a note are not the same as tempered pitches, when they are presented individually, they can be heard as notes in a melody or harmony. This leads to the surprising phenomenon that a single tone can both state a melody and a harmony. Conceptually, this means that the pitch structure of a musical passage can exist on several different levels, in the harmonies and in the overtones. Of course, this can only happen in contexts where these aspects can be brought out through careful control of individual overtones. I would like to illustrate these ideas with examples taken from compositions I have written. The first 6 come from my Harmonic Fantasy number 3. Example 1 presents a single note, E-flat 2, 6.03, with overtones that state the melody and harmony 035. You hear the first 3 notes stating this melody above the fundamental, and the fundamental doesn't emerge until nearly the end of the sound. Since the octave duplications of the fundamental are all stated in a descending manner, it is clear that the E-flat 2 is where it is going. This example uses only 7 harmonics. Example 2 states F2, 6.05, with overtones that state the melody and the harmony 0457. This example uses 13 harmonics. Example 3 illustrates A0, 4.09, the lowest note on the piano, with overtones that state the pentachord 01358. The harmony is more complex, but the melodic notes clearly come out first, and the fundamental doesn't emerge until near the end. This example also uses 13 harmonics. Example 4 illustrates D2, 6.02, with individually attacked overtones and the harmony 0247. It uses 14 overtones, and the fundamental doesn't clearly emerge until near the end of the tone. Example 5 illustrates E-flat 2, 6.03, with individually attacked overtones and the harmony 013. However, after the first 7 partials state 0130, the next 8 state T4 of that harmony, resulting in a single tone that states 2 harmonies. The fundamental emerges quite early but seems to drop out in the middle. Example 6 illustrates F1, 5.05, with harmony 0, 1, 3, 4, 6, but with 24 overtones stated. The fundamental is present nearly throughout, and the overtones create more of an impression of a changing timbre. A striking example of spectral merging occurs in my improvisation number 2. This work is based on the overtones of chords, which are all controlled individually. At about 6 minutes and 30 seconds into the piece, a group of tones that have been undergoing long glissandos suddenly converge on the overtones of A3, resulting in the sudden emergence of this pitch, after which they continue on to different destinations. This clearly illustrates the process of spectral merging. The fundamental emerges from a group of harmonics after a certain number of them have been played. But how long it sustains depends on factors such as how long the partials last and how they overlap one another. Example 8 is the first note, an E-flat 2, from my composition Emergence, which is based on the idea of how the fundamental emerges from harmonic partials. The note begins with the partials that state that harmony 0, 3, 5, 7, and the fundamental emerges when about the 13th partial appears through the tone. However, the durations of the partials are controlled so that only 8 of them overlap at a time, and since all 32 partials are stated, the fundamental drops out at about the 20th stated partial, leaving a dissonant cluster at the end. Nine. The duration of the overlapping of the partials can create significant differences in the way the tone is perceived. Example 9 is identical to example 8, except that the overlap is increased from 8 to 14 partials. The harmonic sequence is unfolded by the time the 13th partial enters. We continue to hear new partials enter, but the fundamental persists longer. As new partials enter, it sounds as both a change of harmony and as a change of timbre. Ten. The next note presents 5 cycles of a low B, 5.11, with an overlapping factor of 12. The harmony stated is 0, 1, 4, 6, 8. You clearly hear individual tones entering, but the fundamental enters in the middle of the cycle and lasts for about half the duration. The cyclic process means that it repeats continuously. However, We also hear the process as a timbre-changing event. (11) In the preceding examples, the partials were attacked individually and the fundamental emerged when enough of them were sounding. In this example, all partials are always present, but each one is emphasized by an amplitude function that plays a cycle of harmonics that emphasize a particular harmony at the beginning of the tone. The result is a rich timbre-changing sound that is not reminiscent of any particular instrument. I encourage you to listen to these examples repeatedly until you can clearly discern the properties I am describing. You may also find that there are other qualities that interest you or that you hear them in a different way. Now I will put all this together into a composition. My harmonic fantasy number 5 was written with many of these ideas in mind. In this work, only the overtones that support the harmony of the immediate context are used. Some tones use as few as 6 overtones, and the maximum that any one uses is 17. The piece opens with a passage that uses only the 8th and higher partials, 3 octaves above the fundamental. The first harmony is 0-1-3, which is clear from the tone's sounding, although none of the fundamentals are present. The notes gradually descend, but fundamentals do not appear until about the 6th section, beginning 2 minutes and 51 seconds into the piece. In the next section, beginning at 3 minutes and 26 seconds, partials are attacked individually but with more harmonics, so that the fundamentals appear as each tone gets about halfway through its total duration. The sustaining instrument reappears about 5 minutes and 43 seconds, and in the last parts of the piece we get a clearer picture of the fundamentals, with tones that sound more timbre-changing than the thin notes with which the piece began. The work lasts 7 minutes and 45 seconds.